Hey everybody, this is Mr. Munson. We are in Unit 2 still, circles. We're looking at concept number 4 from your student learning map. This is arcs and angles, their relationships to each other, continuing on. But in this case, we're going to be looking at when the vertex is on the outside. Let's continue. Let's just do a real quick review of where we're at with circles and segments. So when we're dealing with circles and segments, we learned some stuff in 2.1, 2.2 video. We learned on the left-hand side that we have this kind of scenario where two segments, in this case chords, and they meet inside the circle. Their vertex is on the inside, creating these angles. But we're looking at the chords, the length of the segments, I'm sorry. And so there's this relationship that happens between these four pieces. So hopefully you would recognize it is a partner times partner equals a partner times partner kind of scenario. Over on the right-hand side, we have this scenario where the vertex is on the outside, and again, we're looking at the segments. Now, what you want to do is, as I'm doing this review, see if you can guess, more than guess, maybe you can just confirm in your head, do you know what the relationship is before I write it? If you don't, then you need to go back and watch those videos and do some more practice. If you do, that's a reality. Reality of confidence, okay? All right, so we have vertex on the outside. This particular problem has a relationship that forms between the four segments, and it looks like this. Outside times whole equals outside times whole. Now, if you need more information or a review of that, you should go back and look at the video for 2.1, 2.2. Okay, next up we have on the left-hand side, central angles. Central angles are angles whose vertex is here at the center of the circle. So basically, when we're in the arcs and the angles, we have these angles that cut arcs, as I say, okay? So if you look at angle number 1, it cuts the arc AB. Okay, it's definitely cutting that one. And so the central angle and that arc have a relationship to each other. That relationship is that the angle is equal to the arc. Now over on the right hand side you have inscribed angles, and an inscribed angle is an angle whose vertex is on the center or on the circle itself. Again, angle 1 goes out and cuts an arc, and that's the one it cuts. That angle there and that arc there have a relationship. Do you remember what it is? Hopefully you remembered it is the measure of the angle equals the arc divided by 2. And so if you need to have more understanding of that, you can go back and look at the video 2.3, part 1. Okay, now we have this scenario. Again, we have, in this case, two angles. They're a linear pair. Angle 1 and 2 are going to form a straight angle, but it's basically two separate angles. And so since the vertex is on the circle, this actually has the same relationship as the inscribed angle I just talked about. In other words, this angle right here, in this case, angle 1, cuts this arc, this single arc, and that arc and that angle 1 have a relationship. That relationship, as I just said, is exactly the same as the inscribed angle. The measure of the angle equals half the arc. Okay? The same would go true for angle 2. Okay? So angle 2 would cut this arc, the one on the other side. And so if I was writing an equation and I wanted to write a relationship between angle 2 and that arc, I would use this angle equals arc divided by 2. Then we ended up with a vertex on the inside off center. And when that happens, we find that angle 1, which whatever this measure is identical to this measure on this other side. Can you think of the reason why? It's because they're vertical angles. Okay, so whatever that angle is, angle 1, it cuts this angle, or this arc, but its cousin cuts this arc as well. They're both the same angle size, but they cut different size arcs. And so there's this relationship between angle 1 and those two arcs. And that relationship is that the angle 1 there, is equal to the big arc plus the small arc divided by 2. Now, as I said in the video for this section, it really doesn't matter which one's big and which one's small. When we're adding two numbers, it doesn't matter which one we're adding. It'll become more apparent tonight, or become more apparent in this video, why I'm using the B and the S to help you understand that there's big arcs and small arcs in the order in which we need to place them. But once you'll see that this equation right here looks a lot like another equation, and it'll be helpful in the sense of remembering that they're similar. Now, like the last problem I just showed you, it was a single arc, but it actually ended up a single angle, but it actually ended up being related to two different arcs. We actually ended up adding them and dividing by 2. This is a problem where you have a single angle, here it is, angle 1, and it cuts 2 arcs. Okay? So what ends up happening is this is a vertex on the outside kind of problem. And we've written that before, but we were talking about segments, and the relationship between segments is a completely different world than angles and arcs. So what we're going to have here is this equation. The big arc minus the small arc divided by 2. And since we're subtracting, it's going to be really important that we know which one's the big one. And that's easy to do. It's the furthest out one. All right, let's get into our formal notes. Don't forget to have a summary from the previous lesson. Draw a line. So now we're going to look at arcs and angles with the vertex outside. That last problem I just showed you. Let's write some formal notes now. And there you have it, vertex outside. And so we're going to have a couple of variations of this that might look a little bit different than this one, but you'll get the idea, and you'll understand it as we go through some practice problems. But basically, it's the measure of the angle equals the big arc minus the small arc divided by 2. And the big arc is always the arc furthest away from it, from the angle that's cutting it. Okay, so here's our first problem like this. Let's identify it. Let's write down the formula with no numbers in it. And then let's just put the numbers in it. So as you can see, I just took the 175, which is the large arc, and I subtracted the smaller arc, 57, from it and divided by 2. Pretty straightforward. All right, let's take a look at another one. Again, I see it's a vertex outside. So I'm going to quickly write down vertex outside and then write down my relationship that goes with this type of problem. Plug in the numbers and then just calculate away. So again, here's my angle, so I put it where my angle goes. All right, so the setup of that, let's not even worry about solving that, and let's go ahead and move on to another one. Okay, here you go. Let's have you take a shot at. So as you do these, you want to take note of like where I'm putting information so that you become more and more used to it. Okay, go ahead and identify it, write down the relationship. We obviously know what that's going to be, but it's good practice to do it. Go ahead and write the relationship. Go ahead and put the numbers where they need to be. See if you can do the algebra. I'll see you in just a few moments. All right, there you go. X equals 11. All right, hopefully that algebra wasn't too hard for you. If so, I sincerely hope to see you after school, and let's start doing some of that together and getting you caught up. Now, if you look at the top picture there on the left, it says 2 secants, and so here's 2 secants, and of course that indicates 2 lines, 2 rays, or 2 chords, or 2 segments that touch a circle twice, right? So on the top one, that secant touches in those 2 places, and it's easily observable for the other one. So that's been the problem that you've seen before. Now what I'm going to do is I'm going to draw you a different kind of problem, okay? This one's going to be a secant and a tangent. Okay? So what you need to be able to do is in your mind be able to see that there's still 2 arcs that are formed when this happens. Okay? But the vertex is still outside, so nothing's changed with the relationship. This problem is still the measure of the angle equals the big arc minus the small arc divided by 2. Okay? Let's look at an example. Okay, so we have to be able to kind of visualize what's going on here. Sometimes it's highlighting it. So this arc right here, going from that place where the angle cuts to the other point is 65 degrees. And then from here all the way around up to the other side of the angle is some unknown degrees of x. So let's identify it. Let's take the numbers and put them in place. The angle is equal to the big arc minus the small arc divided by 2. So that arc ends up equaling 13. All right, there you go. Give that one a shot and see what you get. Put me on pause, come back and check your work. And there you have it. X is equal to 6. Now, I could always ask you, what is the measure of this arc? Okay? And you would have to take that and plug it right in there, and that would calculate the measure of that arc. But I didn't. So find X, you got it. Good job. Now this is one where it's actually two tangents. So we've had no tangents, one tangent, here's two tangents. The important thing that you need to realize is the vertex is outside. And that means vertex outside, relationship is b minus s divided by 2. Okay? Let's go ahead and put our number. Wait a minute. There's something missing here. So I have my small angle right here, or my small arc, and I have my angle, but I need something for my big arc. Okay? So my big arc is this one. So I know that the entire circle is 360. I've spent 120 of it already on the right-hand side of that arc. So I can find this side right here by going 360 minus 120. Write that down because I'm going to give you a little bit harder problem next. All right, so once I do that math, I find out that it's 240 degrees for this arc. Okay, now I have enough information to write my equation. Go ahead and put me on pause. I'm going to keep on going, but put me on pause and see if you can do this one. Set it up, solve it, and then just come back and check your work. But I'm going to continue on. Okay, so I find out that x is 3. So now I'm going to ask you, what is the measure of angle ABC? See if you can figure that out. To do that, I would take this number and I'd plug it in right there. And so the angle there is 60 degrees. All right, let's move on. So that's pretty much the cases right there that we've looked at. And they're all the exact same kind of relationship where you have a vertex outside and the angle that we're looking at cuts two arcs. There's the first group. There's the second group. And there's the third group, two tangents. Now, here's interesting enough. In the other ones, the separate arcs don't necessarily add up to 180 or 360, but in the two tangent ones, both these two arcs always add up to 360 degrees. Now let's take a look at this one, this example. So obviously vertex outside. What I'm going to do is I'm going to have you, we're going to do this together, but we're going to do it in stages. And you're going to put me on pause, do the next stage, and then check to see if you make the mistake that's really common with this kind of problem. So be real careful, and it's an algebra problem. Your geometry is probably right on, but it's your algebra that's going to get you kind of messed up. So be real careful. All right, let's go ahead and write our equation. Put me on pause, write your equation. And there you have it. Take a look at those red parentheses. That 13x minus 7 has to be subtracted. The entire thing has to be subtracted from the 190. If you didn't put the parentheses there, then you're only probably going to subtract in your mind that 13x. So put parentheses around it, and that's a reminder that you have to take this negative and send it through to change both those signs. Okay? So go ahead and see if you can work that out to the next step. Okay, I'm going to go ahead and multiply through by 2, and then I'm going to kind of make sure I send that negative through. So put me on pause so you can come back and check to see how you did. How'd you do? Did you get it? So if you didn't get that, you want to go back and kind of look, see what I did, and come and get help from me if you need it. Okay, so I'm going to collect my terms and then start solving. And And there I have it. Okay. All right. That's it. Summary. I wrote my summary. Some of you are writing some pretty lame summaries. I've been looking. And you can take, I really want you to spend just a little bit more time on the summary to really solidify what it is. Some of you are writing fantastic summaries, and I'm very excited about that. This is the first year I've been doing this. I can't wait to see if this results in something fantastic like I've read about. All right, guess what that means? Try it or do it problems. Fantastic, we're done. You are done, except for these do it problems. Get these all done. Bring them in next class, 100%. Excellent. Okay. The last two problems are review problems. So if you're stuck on that, look back at your formula sheets or go back and review the videos that we've looked at before. Let me zoom in, give you a better close-up look at these problems. And on that last problem there, please don't see B is not the midpoint. It is the midpoint. Don't use your eyes to judge if it's a midpoint or anything. Use the facts given, not your eyes, okay? B is a midpoint. See if you can come up with the correct answer for that.